Hello guys, this is Miss Brito here. Today you guys are going to learn how to find the lateral and surface area of a cone. And before we start the first example, I want to make sure you guys understand what a cone is. If you read under today's introduction, a cone is just a three-dimensional figure which consists of a base, and the base will always be a circle, and it also has a vertex. Just a vertex on top where the lateral face meets or intersect. There's also two major key points when identifying parts of a cone. There's always going to be a slanted height, just like on a pyramid. The slanted height can be measured from outside of the shape, from the base all the way up to the vertex. And then there's an altitude or a regular height, which is perpendicular to the base, and it also intersects at the vertex. But the altitude or the height is not the same thing as the slant height. Be careful with those two, because when you form the right triangle that you will have to form later, you need to identify which is the leg and which one is your hypotenuse, just like on the pyramid. So for this example, it says to find the lateral and surface area of the cone with a radius 6 and a height 8. The steps here says that the first thing we need to do is identify the base, and the base of a cone again will always be a circle. Imagine if this was a cone or an ice cream cone, same concept, circular base, and then there's a vertex on top. And to find the area of it, there is always a formula for the area of a circle. So if you go back to previous objectives, in order to find the area of that base or the area of a circle, I'm going to put an O for circle, which is going to be always pi r squared. And then we just go ahead and substitute the values that we have. We know that pi, 3.14 times the radius, 6 to the second power. And when we put that in the calculator or your phones, 6 times 6, 36 times 3.14, or the other way around, this is 113.04. Now, the second step says to identify the slant height. And we should, again, identify it right away, because the slant height is not the one that comes from the center and is perpendicular to the base and intersects at the vertex. This is just the regular height, this blue one. But the slanted height is, it intersects at the vertex, but again, is slanted. It's not perpendicular to the base and it's outside. Or you can see it easier, or identify it if you look at it from outside. So I'm gonna find the slanted height using the appropriate theorem. The best thing to do for this problem is to draw the right triangle that is formed. So I'm gonna have this blue line right here, which is the altitude, perpendicular right here to a base. But then I also have the slant height, which is what I'm trying to find. And this base right here, notice that this base right here from the center of your cone or the circle, the circular base to the circle itself, or intersecting the circle right here, and let's draw that one with a different color. This piece right here, or this segment right here, is your radius. Again, if you have a segment that goes from the center of the circle and it intersects your circle, that is going to be your radius. And that information was provided to us. That's 6. And the height was also provided to us. That is 8. But we need to find the L, or the slanted height. So how do we find the slanted height? We're going to use the Pythagorean theorem. Whenever you have a right triangle and you have two segments and you're missing a third one or a third side, you always use the Pythagorean theorem. So it's going to be c squared equals a squared plus b squared. My c squared, or the c is always the hypotenuse, and the other two are interchangeable, but don't confuse the hypotenuse with any of these two legs or you get it wrong. C squared is what I'm trying to find. It's gonna be 8 squared plus 6 squared, or 6 squared plus 8 squared, same thing. C squared equals 64 plus 36. C squared is 100, and the square root of 100, that is 10. And again, this is the same thing as L, or the slanted height, this piece right here. Now I'm gonna find the lateral area, and to find the lateral area, there's a formula. The lateral area is just pi r times the slanted height, and that is step 3. I'm gonna bring it over here. Step 3. L, or slanted height, equals pi r L, or slanted height. L equals pi times my radius, 6, times the slanted height that I found, which is a 10. And if we put that in the calculator, 6 times 10 is 60 times pi. That is 188.4. 188.4. And finally, the surface area is going to be just like on previous objectives. The surface area is just the sum of your lateral area plus the base area, and there's a formula for it. But again, this is just the lateral area. Notice that this piece right here, pi r L, is just the lateral, which we already found, plus pi r squared, which is the area of the circle. So it's basically L plus B. So this L right here, or lateral area, surface area is going to be lateral area 188.4 plus the area of the circle, which is 113.04. And then when I add that in the calculator, I get 301.44. Don't forget your unit square, and that is centimeters to the second power. Shoot me a text or an email if you have any questions, and good luck with your worksheet.